I recently read about an awesome project that I really wanted to tell you about. There's a group of people who are working under the Earth BioGenome Project, which was officially launched just a few days ago, on November 1st in London. Researchers in the United Kingdom plan on spending about £50 million, or $65 million, to sequence the genomes of all of the eukaryotic species that live in the country, which is estimated to be slightly below 70,000 species. Now, this is a global project. It's not just limited to the United Kingdom, it's global. And to date, there have been more than a dozen other pledges from all over the world, totaling close to $200 million that's been pledged to be spent on genome sequencing. This BioGenome Project has a decentralized organizational structure, and there are some advantages to this. Instead of having a single research hub or a single colossal research effort, the project is built around a large number of smaller groups, each doing their own limited research. The only centralized effort in the project will be to standardize the data collection methods, and then to collect, consolidate, and organize all of the generated data into a cohesive whole. I'm imagining a biological search directory, with gene sequences instead of phone numbers, and organisms instead of faculty. The BioGenome Project has multiple goals, and for many of these goals, they're broken down into phases, things that you can reasonably achieve step by step. For example, a Phase 1 goal includes sequencing the genome of at least one species from every known eukaryotic family, and there's more than 9,000 such families. So this Phase 1 goal is pretty big, but it's doable. It's easily within the realm of achievability. Now the ultimate goal here is to sequence the genome of all 1.5 million known eukaryotes across the world, be they animals, plants, fungus, or protozoans. As I'm sure you're thinking, yes, this is going to be a titanic task, and it will cost an estimated $4.7 billion. But the cost will be well worth it if we can catalog the genome of enough species before they go extinct. By generating all of these genetic data, we can better understand ecosystems and biodiversity, and gain a better understanding of evolutionary relationships. But perhaps most importantly, this will be of huge benefit to us in the form of medicines, agricultural methods, biomaterials, and biofuels. We use chemicals that we find in nature, like the protein or something that's in an animal's blood or saliva, or some alkaloids found in a plant or a fungus. We use these chemicals for all manner of things, and the most obvious being pharmaceutical drugs that save people's lives. We've created very few medicines just from scratch. Almost all of our medicines have come from these natural products, and we do a little bit of chemical tinkering to perfect them or optimize them or to specialize those chemicals for, certain medicinal functions. But the base truth behind all of this is that the chemicals that we use for our medicines come from flowers and fungus and animals and all sorts of wild things that we sample and take gene sequences from. But with climate change and human impact causing extinctions across the biosphere on a scale that we've never seen before, we are losing this critically valuable biodiversity. And with it, we'll be losing any medical or technological innovations that we could have discovered. So projects like the Earth BioGenome Project are extremely valuable because they'll allow us to permanently record the biological data that, right now, only exists in the cells and the tissues of real animals and plants and fungus living out there, somewhere in the wilderness. This project will allow us to sample our biosphere in a way where we can still perform research and discover new drugs, even if the actual species whose genome we're studying has been extinct for years. So in a manner of speaking, this BioGenome Project is all about biochemical redundancy. It's like a safety feature or a precautionary measure. We're taking all of this data and doing all of this research while we still can, before these organisms are wiped off the face of the earth. But to do this, we'll have to act fast, because every species that goes extinct before we can sequence its genome and study its biochemistry represents an immeasurable loss of potential medicines and biomaterials and biochemical compounds. Here's to hoping that in a decade's time, the Earth BioGenome Project will have come a long way and will have made significant progress towards accomplishing its goals. Because from a long-term perspective, this is the kind of research that can safeguard human civilization. I don't think that's hyperbolic to say, considering we're in the middle of a giant mass extinction event of our own making.